Guys, so today we are just going to solve a couple of questions from the tutorial set. We've already tried the question 1 and 2, so I would want to go through the question 3 and try some other difficult questions that could be helpful. So the question says, suppose M is the midpoint of AB, where A and B are some points given to us, and also if P divides AB internally and Q also divides AB externally in the ratio 2:3, show that MP times MQ is equal to the square of MB. So with a question like this, you can just try representing the whole idea graphically to see what to do. So assuming this is AB, where we have our A here to be 8, 10, and we have our B here to be 18, 20. I think it's too deep, guys. Let me just reduce it. Okay, so in case we have our M as the midpoint, so I can use this place to be the midpoint and call it M, and that is going to be, say, SY, right? And we are told that P divides AB internally in the ratio 2:3, right? So basically from A to 2, right? Because 2 is the least number, so from A, between A and M is where P should be. P won't have to be after M, so I can indicate here as my P, so that from here to here will be the 2, and that would mean from the P to the B will represent the 3. So that is for the internal division, right? The internal division. Then we are told that Q divides AB externally in the ratio 2:3. So I am to also indicate where Q will be. Remember, when it's about external division, it means that the division occurs outside A and B. It occurs outside A and B. So I would have to make sure Q is outside the line AB. And we will have to consider the ratio 2. Given the ratio to be 2:3, it means that Q is still closer to A than B. So whatever extension we are doing for the first ratio 2, we should do it from A. So I'm going to the left hand side because the external space beside A goes to the left hand side. So I extend this to the left hand side like this, and I can call this place Q, and maybe, yeah, so I will just call it Q. And this Q, this distance from A to Q is also 2, but it goes in the opposite direction as the first one, so it is basically a ratio, a negative ratio. Remember, we said that is why we said always we negate the negative one. So the distance is 2, but the actual value of the ratio becomes negative of that value. And the whole idea is from Q to the B is going to be 3. So negative 2 and 3 becomes the ratio. So the internal division ratio, we would want to make it N:M, is going to be 2:3. Then the external ratio, which is also going to be N:M, though we will negate one of them, is also going to be from the 2:3. So right after writing this, you just have to look at it and negate the smallest value. 2 is the smallest value, so I negate it. That is why I had to negate it in the diagram. And we can do same for the N. So minus N goes with the -2, and M goes with the +3. So this is basically the diagram we have. And the first question says, or the only question says, we should make sure, or we should prove that the length of MP times the length of MQ is equal to the square of the length of MB, right? So we will just take them one after the other and solve. So we would first of all have to know the midpoint M, right? So we know that M of xy as a midpoint formula is s1 plus s2 all over 2, y1 plus y2 all over 2. And this basically is equal to, so I have the point for A and B already given. So let's this one be our first point, and let this one be our first point, and let this one be our second point. So that would mean that s1 is 8, s2 is 18 all over 2, and y1 is 10, y2 is 20 all over 2. So eventually we have 24, I think that is 26 actually, 26 over 2 against 30 over 2, which is giving us 13 against 15. So that is the midpoint. Now I can bring this question here. So now we have that the MP, which is the length we are finding, the length MP has the formula to be the square root of s1 minus s2 squared plus y1 minus y2 squared, right? And that is going to be the square root. Remember, we have the p already. Okay, unfortunately we don't have the p, so that is one thing we would have to do first. We would have to also calculate the p quickly, so let me quickly do that. So let me just clean the formula for the meantime, just as we are trying to find the p. So we just found m, we would also have to find p. So also p is the internal division, which we already know. I'm just trying to rewrite it so that we would state the ratio. So it has the ratio n is to m, which is equal to 2 is to 3. So this way we can easily create the formula for p, which is the internal division. So p is, remember I said the formula is always similar to the midpoint formula. It is always similar to the midpoint formula, which we consider both the y1 and the y2. Just that in this instance, whilst we divide the midpoint formulas by 2, here we would be dividing them based on the ratio given, because normally in the midpoint formula the assumption is the ratio is 1 is to 1, right? But in this particular instance we have been given that the ratio is n is to m, so the sum wouldn't be 2 like we see in the midpoint formula, but it is going to be n plus m. At the same time, this time they have weight, that is the x1 and s2, y1 and y2 this time have weight, so we would have to multiply them by their weight, and their weight are going to be from the m and the n. Now the only trick here is the first value of the ratio goes with the second coordinate, right, of the coordinate. Yeah, it goes with the second coordinate, and the second value of the ratio goes with the first coordinate. So basically I would have to now multiply x1 with m, because m is the second value of the ratio, and I would multiply the second coordinate with n, because n is the second the first value of the ratio. Then I add the two ratio at the denominator. I do the same here, so I have m, n, and m plus n. Then eventually I close the bracket. So this is our formula for the internal division. Then the rest is just evaluation. So m is 3, S1, that is, we are still dealing with A and B. So just to recall A and B, we can write the value of the coordinate of A and B here, which is already in the question anyway. So that is 8, 10, and B is 18, 20. This is actually S1, this is Y1, this is S2, and this is Y2. So 3 times S1, which is 8, plus N, which is 2, times S2, which is 18, all over 2 plus 3. Then we have 3 times Y1, which is 10, plus 2 times Y2, which is 20. Yeah, this is actually 20. And we have 2 plus 3. We close the bracket. So here we just do this simplification, and by doing the whole calculation, we are expected to get the P as 12 and 14 after you have done all the calculation. Yeah, this is what we get. Then we go ahead for the MP this time, because now they said we should be able to find MP, which we wrote initially as the difference in the x coordinate squared plus the difference in the y coordinate squared. And that we have everything already. We have mn. Yeah, we have mn p already. So we just do the substitution. So let m be the x1, s2, and p be there. So m is actually what we have here, and p is just what we found. So we just do the difference between m and the p. So we have 13. Let me use the black pen. So 13 minus 12 squared plus 15 minus 14 squared, and this is going to be square root of 1 plus 1, which is square root of 2, right? So we are done with MP. We will have to also find MQ, but so far we don't know Q, so we would have to find Q also. So in finding Q, we know that Q is the external division, right? So that would mean I would have to know the ratio, and the ratio we know as n is to m, which we said is 2:3. But because it is an external division, the least value should be negated. So I negate the least value, which is the 2. It becomes -2. I repeat the same for the n. Now, once I repeat the same for the n, it means that I can now use this representation -n and -m and repeat the same formula in the internal division, just as we have done here. So instead of using n is to m, we are now using -n is to m and repeating everything about the internal division formula, and that will give us the answer. So you don't have to assume the external division formula is different from the internal division formula. Once you get the ratio correct, the rest is repetition of the internal division formula. So I am basically, like we said, and the internal division formula is also from the midpoint formula. It's just a generalized format of the midpoint formula. So assuming we are using the midpoint formula approach, where we just sum the coordinates from y and s and divide by 2, this time we are applying the weight, which is the ratio. So we have the second value of the ratio goes with the first value of what? The coordinate. So m will go with s1, then s2 will go with -m. Like you can see, it has a plus there, so I'm cleaning it. Then I now write my -m there. I divide it by, sorry, it's actually -m. I divide it by the 2, so the summation is actually, you can even, to be sure, you can even make it as -n plus m, which is the same as m minus n. So anyhow you put it is correct. So I come here, I apply the same approach. That is m against minus n, and here I sum the two ratio. That is, I put the two together. Here I did minus m plus m. Remember, it is the same as m minus n, so I can rather write m minus n here. I'm doing it different so that you get to know that however you represent them doesn't matter. They still mean that you are summing the two ratios. So from here I can now do the evaluation. So we know our a and b, right? We had written it up there. We can even repeat it here again, but it is also in the question here. It is also in this question up here. So I'm going to look at the one in the question. So m is actually 3, and s1 is going to be 8 minus n, which is minus 2. Then s2 is going to be 18 all over minus n, which is minus 2 plus 3. I do the same for the y. So 3 times y1, which is 10, minus 2 times y2, which is 20, all over 3 minus 2. Remember how I arranged them. So minus 2 plus 3 and 3 minus, they are all the same. So however you put it, addition is commutative. So however you put it doesn't really matter. Then finally, we have our answers for the Q as minus 12 against minus 10, like this. So we now can go ahead and calculate for MQ, which we already know the formula as square root of the difference in the x coordinate squared plus the difference in the y coordinate squared. So all I have to do is to evaluate, do the substitution. Remember, we are using m and q. Q is what we just solved here. And remember that m from the question we solved is actually 13 and 15, right? So with these two values, we are doing the evaluation, and that is going to be, so x1, if m is x1, y1, then we have 13 minus 12, which is going to be positive eventually, plus we would also have 15 minus 10 all squared. Remember that it is two negative, so this place becomes positive, this place becomes positive. Eventually we have square root of 25 squared, right, plus square root of that side is also 25 squared. So that makes our calculation easier without a calculator. So 25 squared plus 25 squared is actually 2 times 25 squared. So this way I can just apply my set ideas, and that eventually gives me 25 root 2. Yeah, so MQ is 25 root 2. So from here, I will go ahead and multiply the two quantities we just calculated. According to our question, we should know the product of MP and MQ. And that we had the MP to be root 2. We have it here. Then we have MQ to be 25 root 2. So I'm just adding the two together. So that is MP, which is root 2, times 25 root 2, which is the MQ. And this is basically giving us 25 times 2. Remember our set properties. So that eventually gives us 50. Now I'll go ahead and also calculate the right hand side from the proof. We are told that MB squared should eventually be the same as the left hand side. So let's go ahead and calculate that. At least we know the MB, the length of MB is just going to be the square root of S1 S2 squared plus y1 minus y2 squared. But we are dealing with the square of this formula. Or another thing is you can just go ahead and calculate just mb. So once you are done, you calculate the mb squared. So let's assume we are calculating just mb. So we go with just this formula. We do our substitution. Remember, our m is 13, 15, and our b was given in the question as 18, 20. So with these values, I just look at it and do the substitution, and that is going to give us 13 minus 18 squared plus 15 minus 20 squared, and that eventually should give us 5 squared plus another 5 squared, and this we can simplify just like the other one as 2 times 5 squared, right? And this by indices is going to be 5 root 2. So from here I now have to find mb squared, that is the square of the answer I just had, which is 5 root 2 squared, and by application of indices it is just 5 squared times root 2 squared, and that is 25 times 2, and that is also 50. So this obviously implies that mp dot mq is equal to mb squared, which we had as what? 50. Yeah, so that ends the first question. So for the next question, I will just have to type that question because I don't have it written yet, and it's a very interesting question. So the question says a point A, which is 1, 2, is, yeah, so this is the question now. So a point A 1, 2 is one vectors of a parallelogram ABCD. Then we have side AB lie on the line 2y equal to x plus 3, and the diagonal BD lies on the line 3y equal plus x equal to 17. We are told that if the line AD is equal to the line BD, then we should find the coordinate of C, and we should also find the equation of the perpendicular bisector of AB. Now, like I've been saying, if you are given a question like this to solve, usually it is appropriate you get to sketch that question, then that would guide you in knowing how you would solve it. So we are going to draw the question on an XY plane, or more or less summarize the question on an XY plane so that we get to understand it more. So we have that this line and this line, then we are told that the point 1, 2 is one of the vertices of the parallelogram we are coming to draw. So assuming here is 1 and here is 2, we can have this point as A, right? So that is one of the points of the parallelogram we are coming to discuss. And we are also told that the side AB lies on this line here, 2y equal to x plus 3. So we have to draw that line, and usually, like I say, we can easily use the intercept of the line to draw it. So assuming the line is 2y equal to x plus 3, now if x equal to 0, or if x equal to 0, we can see that y will be equal to 1.5 by some simple evaluation. So this gives us 0, 1.5 as one of the points, and if y equal to 0, the x-intercept will be x equal to minus 3, and that gives us minus 3, 0. So I am supposed to plot 0, 1.5 and minus 3 0. So 0, 1.5 could be somewhere here, and minus 3, 0 could be somewhere here. So remember, that same line already lies on A as well. So the point we already plotted here, it is such that once we draw the line 2y equal to s plus 3, it should also pass through the first point we plotted. So this is basically a straight line passing through these lines like this, a very nice straight line. So this line I have drawn is called 2y equal to s plus 3. We will need that line so much. Then the next thing we were given is, and the diagonal BD lies on the line. So we have been given that the diagonal also lies on another line. The line is 3y plus x equal to 17. So we will have to also sketch that line. Then we get to know where we will indicate the point B and D. But one thing we know is the point B and D is already, the point B is already on the first line we drew. So wherever the next point, the next line we draw cuts the first line, that is where we call B. So let's draw this line. So using the same intercept, if y equal to 0, we get x to be equal to 17. So that is one of the first points, 17, 0. And if x equal to 0, we will get y to be equal to 17 over 3, and that is going to be, so 15 point 5 point something, right? That is 5.6, sorry, that is 5. So 5.6. So eventually we have the point 0, 5.6. So I'm going to plot that line. So 17, 0, I can bring it somewhere here. Let me bring 17 here so that this place will be 17, 0. And let me bring, remember this is 2. So 5 can come somewhere here. Maybe somewhere here can be 5. Then I draw a line to pass through these 2 points I just plotted. It may not look nice, but I'll try. Okay, let's manage this line. So wherever the 2 lines just cuts is where we should call B. So I'm going to call this place B. I don't know where to indicate that B. Let me just bring it here for the meantime. So I have A and B already indicated, but this same line I just drew, which we are calling 3y plus s equal to 17, it also has the point D on it. But remember, it's a parallelogram we are drawing, so we want to make sure the order of the label is taken into consideration. So I have A here, I have B here. If I should have D on anywhere on this line, for example, then it means I should be told where C is. So C should be somewhere in this region, right? C should be somewhere in this, so that it can follow in the form of A, B, C, and D in the anti-clockwise direction. So I am going to call C somewhere here, but it's a parallelogram. So first of all, I will join A and D because I've already indicated D somewhere here. I'm going to join A and D. Let me maybe reduce where D is. Oh no. Yeah, so let me just reduce where D, let me bring D a little closer because of space. So let me call this place D. Then I'm going to join these 2 lines, D and A. So that is the line for A. Let me draw it again. Okay. Then I will have to draw another parallel line in that order to join the B and the C. So let me start from here and draw a straight line, some line as parallel as possible. Okay, then I join the one here too. Okay, eventually I have that place to be my C. Sorry, it is inside the second question, but let me call it with this color. So I have my parallelogram already, but remember we have already discussed one of the diagonals of the parallelogram, so it's better I also indicate the other diagonal. So I'm going to indicate the other diagonal like I did because we will need it. So we know something about the diagonal BD. We don't know anything about the diagonal AC, but eventually we have to solve the first question as the coordinate of C. So obviously the diagonal AC will be needed. Now we have our diagram. Thank God, it means we can go ahead and quickly solve for the question. So the first thing we would want to do is to find maybe the point B. Remember, our focus is to find the coordinate C, but I feel like when we solve for the point B, which we can easily solve by solving these two lines simultaneously, so maybe line L1 and line L2, once we solve them simultaneously, we can now know the point of B, then that can lead us to something. And another property we may need here is that the two diagonals bisect each other. So because they bisect each other, it means we expect some midpoint somewhere here, and that midpoint will play a very huge role in getting us the coordinate of C. So let's quickly delve into solving for B. So we have that. So we solve for B by solving L1 and L2 simultaneously, right? So we have 2y minus s is equal to 3 as our L1. Then we have 3y plus x is equal to 17 as our L2. So by solving them by elimination method, we can easily get 5y equal to 20. And that is 5 over 5, giving us y to be equal to 4, right? So we can now substitute y equal to 4 into maybe L1. And L1 is the first equation here. So that implies that we have 2 times 4 minus x equal to 3. So eventually we have 8 minus 3 is equal to x. That means x is equal to 5, right? So by this point, it means we have the point B to be 5, 4. We need it so much. So let me go back to the diagram and indicate the point B. So we just had the point B to be 5, 4. We just had the point B to be 5, 4. So we now have that point. That means we can now go ahead and find another thing that can help us solve something. But one of the things that we can easily solve is the fact that we know that AD is equal to the line BD, right? AD is equal to the line BD. So we know A now, we know B now. The only thing we don't know is D, meaning we can generate some equation from that two equality given to us. So let's make D some particular point. So let's say D be AB, right? So let me make D AB. So but AD is equal to BD. Therefore, let D be equal to AB. Then that will imply that the length of AD, which we have the formula as the difference in S coordinate and squared and the difference in Y coordinate squared, is going to be the square root of. So we have A already. Remember, we have A also given to us as 1, 2. So I'm just doing the substitution with this. So we have 1 minus A squared plus B minus 2 squared, right? And I can do the same for BD. And that will be also the same formula. And that is going to be, so remember B is what we just solved, 5, 4. So I'm using D and B, and that is going to be A. So I can put it any form I want. So I want to go with the variables, the letters first. So I think I should have done that for the first one. So let me go for maybe A minus 1 instead. Yeah, it doesn't matter, I just interchanged it. So this one too, I would want to start with the letters first. So that would be A minus 5 squared plus B minus 4, right, squared. These two are equal, so I just come down here to equate them. So therefore we have that square root of A minus 1 squared plus B minus 2 squared is equal to the square root of A minus 5 squared plus B minus 4 squared. We want to eliminate the square root, so that's it's by squaring both sides. We now have, so I can just square both sides, and that gives us A minus 1 squared plus B minus 2 squared is equal to A minus 5 squared plus B minus 4 squared. So this is one of our equations. Let me call that equation star. Yeah, because we are seeing two variables here, it means all we have to do is to at least get another equation in terms of A and B, then we solve them simultaneously, because it's now an equation of two variables. So to be able to find A and B, we need another equation so that we can solve them as two different equations in two variables. So one fortunate thing is the point D, which we just called A, B, when we come to this diagram, is lying on this line, right? The point D is lying on this line, and we know this line to be 3y plus x equal to 17, meaning that point D actually satisfies this line here, right? It satisfies this line. So that is the line L2 to remember. So all I have to say is, but D, which is AB, satisfies L2, which is 3y. So let me check the equation well. So 3y plus x equal to 17 equal to 17. So that implies that 3b plus a is also supposed to be 17. Now all we have to do is to solve equation star and equation star star simultaneously. So we solve equation star and equation star star simultaneously. So therefore we solve equation star and star star simultaneously. All the friction on my tablet is gone. It has become very slippery, unfortunately. Sorry about that. I have to change the tip of my pen. So I now go for those two equations and solve them simultaneously. So to do that, I would borrow, so from equation star, I want to solve it with the substitution method. So from equation star star, we would have a to be equal to 17 minus 3b, right? Let me call this equation maybe 1. We don't have equation 1 yet, so I'm going to put equation 1 into equation star. So we put equation 1 into equation star. So wherever I see a in this big guy here, wherever I see a, I'm going to put 17 minus 3b there, right? So let me just make it this way so that I can write it quickly, then we start using it from here. So the first expression we see is actually that. I'm writing it in orange now. So I have 17 minus 3b minus 1, right, squared plus, now we repeat b minus 2 squared, and this is going to be another 17 minus 3b minus 5, right? And that is also squared, plus b minus 4 and also squared. So we have done the substitution. Now fortunately we have an equation in terms of only b. All I have to do is solve this equation after simplifying everything. So I have here 16. After the substitution, I'll have 16 minus 3b squared plus b minus 2 squared is equal to, here too I'll have 12 minus 3b squared plus b minus 4 squared, right? So I would quickly expand. So I think, yeah, let me just expand the right hand side and something nice will happen at the left hand side. So by expanding the right hand side, 16 squared is going to be 256, right? Then we have 3 times 16, which is 48, times 2, which is 96, right? So minus 96b plus 3 squared is going to be 9b squared. I also expand the second term. That was going to be b squared minus 4b plus 4. And this left hand side, if you look at it well, we already have it as, I can factorize the 3 here. So it is going to be 3 4 minus b all squared. So 4 minus b with a big bracket all squared plus b minus 4 all squared. And whilst I repeat the left hand side, the right hand side is also going to be 9, basically, because, so 9 4 minus b squared, right, plus b minus 4 squared. And if I repeat the left hand side again, here at the right hand side, 4 minus b squared is actually the same as b minus 4 squared, right? So basically I could have I can write 9 into bracket b minus 4 squared this way, so that I can now do what I want to do. So 9b minus 4 squared plus b minus 4 squared is actually 10b minus 4 squared, and still the left hand side is repeated. So now I can go ahead and expand the right hand side whilst I repeat the left hand side. So far we have 2, so I have a 4 here and I have 256 here. So when I add the 2 together, it becomes 260, right? So I have 260. Then the b's, 2, I have minus 4b here and I have minus 96b here. When I add them, it becomes minus 100b. Then the b squares 2, we have 10b squared. I think now you can see where I'm arriving at. So at the right hand side, we are going to have 10 into brackets b squared minus 8b plus 16, right? Now I finally expand the right hand side and you see a lot of things cancelling, making our equation very simple now. And that is 10b squared minus 80b plus 160. So 10b squared cancels 10b squared at the right hand side. Then we have 100b and 80b. So I'm just going to group all the b's now. I would like the 100b to move, and so I'm making the 260b to stay. I am bringing 160b to the left. It becomes negative now. Then I already have 180b at the right. I let 100 minus 100b cross. It becomes positive 100b. Eventually we have 100 is equal to 20, right? 20b. So I divide both sides by 20. Finally I have that b is equal to 5, right? I can quickly solve for a. Then remember we had some equation 3. Sorry, equation 1. So this equation here is equation 1. I'm going for equation 1 to put b inside. So put b equal to 5 into equation 1. So put b equal to 5 into equation 1. And equation 1 was a is equal to 3y minus 3b 17 minus 3b actually, 17 minus 3b. So 17 minus 3b, which is going to be 17 minus 3, 5, which is 17 minus 15, and that is what, 2. So therefore our point D, which we knew as AB, is now going to be 2, 5, right? Now let's go to the diagram so that I show you something interesting. So we just solved for D, right? This point is D, and we are now saying D to be 2, 5. So we know D, we know B, and we know that the midpoint of BD is M, which is easy to solve since we know B and D. So we'll go ahead and solve the midpoint of BD. Fortunately, the midpoint of BD is the same as the midpoint of AC. Remember that we already know A to be 1, 2. So once we solve the midpoint of BD, we can now use the midpoint of BD, which is the midpoint of AC, to help us find the C. Then we are done, because we have A and we will have M. So together with A and M, we solve for C using the same midpoint idea. So let's go and find M, which is the midpoint of BD. So we solve for M, the midpoint of BD. So we know that the midpoint formula is actually the sum of the x coordinate over 2 and the sum of the y coordinate over 2. So quickly I do the substitution. We can recall the point B and D. So B we actually had as, I think, 5, 4, and D we have now as 2, 5. Let me quickly confirm the B once again. Yeah, so B is 5, 4. So I'm doing the substitution. It will be 2 plus 5 over 2 and 4 plus 5 over 2. Eventually we have 7 over 2 against 9 over 2. So all I have to do now is to go and find my C from the diagram, remember. So from the diagram we have the line AC. Let me draw the line AC here. So we have the line A, the line C, and we just realized that we know M. So A is 1, 2, M is 7 over 2, 9 over 2. So we just go ahead and solve for C, which is P cubed. So let me call C P cubed, then we go ahead and solve for C using the same midpoint formula, right? So what I'm coming to see here is, but M is the midpoint of AC. This implies that M is equal to, which is equal to the 7 over 2, 9 over 2 we solved. It's actually going to be S1 plus S2 over 2, Y1 plus Y2 over 2. Now when I do the substitution with the A and C, remember we know A and C. A is 1, 2 according to the question, and fortunately we are looking for C. We've represented it with P and Q. So I would have 1 plus P over 2 and 2 plus Q over 2. So we just do comparison here. This point is not different from this point. So I expect that my 7 over 2 is to be equivalent to 1 plus P over 2. And my 9 over 2 should be equivalent to 2 plus Q over 2. So the rest is for me to just calculate. Now the denominators are the same, so we can quickly say 7 is equal to 1 point p, and 1 plus p, that means p is equal to 6. And here too, denominators are the same, so we can say that 9 is equal to 2 plus q, and that would mean that q is equal to 7. So therefore we have the point C, which we are looking for as PQ, to be equal to 7, right? A very interesting question. To be equal to 6 against 7. So that's our first question we were told to solve. Now we go ahead and solve the next question. The next question II says that we should find the equation of the perpendicular bisector, which I'm going to represent like this, of AB. So what does that even mean? Now the part that is called AB in the diagram, we are told to find a line that bisects AB. So let me use an orange. So a line that bisects AB at the same time is perpendicular to AB. So we can learn two things from this, right? We can learn two things from this: that the line passes through the midpoint of AB, at the same time is perpendicular to AB. That is, it creates an angle of 90 degrees with AB, and that brings some idea about the gradient of these two lines to us. That says that if the two lines are perpendicular, then the product of their gradient is -1, or the gradient of one is the negative reciprocal of the gradient of the other. So like I said, we have AB given to us from the question. We have A to be 1, 2. We have B to be 5, 4. Let me confirm once again. B. Yeah, so B is 5, 4. And we are told that we should find this black line that is basically perpendicular to her. So this is our perpendicular bisector line. So I'll quickly find the midpoint, which is M. So this time let me call it M perpendicular, so that it will identify it from, or I can call it a midpoint of AB. So midpoint of AB, I can also call it as MAB, like this. And we know the formula as always. That's one of the formulas you should always know, and one of the tricks in being good at analytic geometry, being familiar with the common formulas. So remember, we know A and B already, so we just substitute. It's going to be 1 plus 5 over 2 and 2 plus 4 over 2. That is basically giving us 3, 3. So from here, we just go ahead and find the gradient too. So gradient of, which is a small m, of the perpendicular bisector is basically supposed to be -1 over the gradient of AB. And if you can recall, AB was actually a line, was passing through a line. So once we know the equation of that line, we can know the gradient of AB, right? So I'm going to find the gradient of AB through this line. So we know the line to be 2 equal to s plus 2y equal to s plus 3. So that is gradient of AB. Let me do this here quickly. So let me, oh melt. So but AB lies on line 2y equal to s plus 3, right? So this implies that y is equal to 1/2 x plus 3/2. Therefore, the gradient of AB is actually the coefficient of x, which is 1/2. So when I come back to what we were solving, we will have that the gradient of the perpendicular bisector is going to be -1 over the gradient of AB, which is what? 1/2. And finally, we have -2 to be the gradient of the perpendicular bisector. And remember, we just solved for the midpoint, which is also on the perpendicular bisector. So we use the midpoint and the gradient to find the equation of the perpendicular bisector. So therefore, the equation of the perpendicular bisector is, so I just go to the formula and I use it. So y minus y1 equal to m into bracket s1, sorry, that's actually s minus s1, and we have everything already. The point is 3, 3, and the gradient is -2. So I just look at those two information to solve it. So I have y minus, the point is 3, gradient is -2, s minus 3, and we simplify this. We have y minus 3 equal to -2s plus 6, and finally we have y plus 2x is equal to 6 plus 3, which is going to be 9, right? So that is the equation of the perpendicular bisector. Alright, so I would quickly take another last question to solve, then we are done. Right, so I'm going for the tutorial set, and in the number 10 of the question from the tutorial set, I think we can use that to do a lot of things. It explains something we have learned already, so I'd want to go for that question quickly. So we come back here, then we come to use this question. It has given the line L with equation as plus by plus c equal to 0 and the point s1 y1. Show that this line is parallel to L. Parallel to L is given by this. Okay, this question is really easy. That is not the one I intend to solve actually. So let me quickly go for another question. Yeah, so from the tutorial set, I can just ignore this one and look for that question. Yeah, so that is number 12 actually. So we want to find at what angle two equations of line incline each other, and because the equations of the line are actually variables, I think it's a very nice question to explore with variables. So at what angle are the lines AS plus BY plus C equal to 0 and the line A minus BS plus A plus BY plus D equal to 0, where A, B, C are all greater than 0, inclined to each other? So we are looking for an angle where two lines, so assuming this is L1 and this is L2, so L1 and this is L2, so we assume that L1 and L2 are meeting at a certain angle, which let's say we will call theta. We want to know where that angle, what that angle is, but unfortunately we don't actually know the equations in variable form, but fortunately they would all vanish by the time we are done solving the question. So we quickly have to remember one of the formulas we've learned so far from our previous studies that talks about finding an angle between two lines. And if you can recall, we would need the gradient of those two lines and some formula from the trig ratios with respect to tangents that gives us some particular information about the angle between the two lines, right? So first of all, let's remember that to find the angle theta between these two lines, we need the formula that tangent of that angle is supposed is going to be the difference between the gradient. So the gradient m1 minus m2 divided by 1 plus the product of those two gradients, right? So this is the formula we need, but we would have to solve the gradients m1 and m2, and fortunately we can get them from the equations. Because we have the equations, we make sure we put the equations in the form y equal to ms plus c, like we did in the previous question, so that we can get it. So for L1 we can have it as by equal to minus as minus c, and this implies that y is equal to minus a over b s minus c over a, right? So this finally implies that m1 is equal to minus a over b. We are taking the coefficient of x. So for L2 we have that the b part, so I will have to, the y part of the equation is a plus by, and that is equal to minus a minus b s plus d, and that implies that y is equal to minus a minus b all over a plus b s plus d over a plus b, right? And this finally means m2 is equal to minus a minus b over a plus b, right? So we need these two gradients we just found into the equation, or that is the formula actually, equation star. So all I'm going to do is to put these two gradients into the tan theta. So therefore tan theta is going to be m1, which is minus a over b, minus m2. Remember the m become 2, right? So the m become 2, or I can even I could have simplified it, but let me leave it as it is. So I'll have another negative, and that will be a minus b all over a plus b. So because the negatives are 2, remember it will turn to positive eventually, and the denominator becomes 1 plus the first gradient, which is minus a over b, and the second gradient, that is minus a minus b over a plus b. I can simplify this somehow to something we can easily deal with. So I would have to combine the numerator first into one fraction, and I do same for the denominator. So we can have an LCM for the numerator to be a plus b times another b, right? So we multiply the two denominators at the numerator to be the LCM, then we deal with the numerator. So eventually we have minus a plus b for the first term. This place becomes positive, remember, so I have it as plus, b multiplying a minus b. I will have the same idea at the denominator here. So at the denominator here too, we would have the LCM to be b minus, that is supposed to be so I'll have b into bracket a plus b, then the first term is going to be just b a plus b, and the second term, the two of the negatives there are multiplying, so we would have a into bracket a minus b. So from what we have here, I'm simplifying the numerator. Remember, we have one numerator here. I'm going to simplify the down one, but at the same time I would be changing this sign, this division sign, to multiplication. Remember how we apply our operation rules. So I have the numerator to be, I can expand it if I want, so I'm going to expand it whilst trying to do, so I'm doing a lot of things at the same time. So minus a squared minus ab plus ab minus b squared, right? That's the numerator, divided by b into bracket a plus. So this is basically we solving tan theta. So I just want to push it a little here. Then I have tan theta is equal to what I'm writing. And the division sign I just talked about here, I'm going to change it into multiplication. So the denominator comes first, that is b, a plus b over the numerator, that is going to be me expanding it. So ab plus b squared plus a squared minus ab, right? So eventually some things are cancelling, so this cancels this, and on the numerator too we have a few terms cancelling. So we have that minus a squared minus b squared is left, and the denominator here too we have a squared plus b squared left. Maybe we can do some simplification. If I factorize minus on the numerator, I have a squared plus b squared, and the denominator here to have a squared plus b squared, and finally this is giving us a minus 1. Now if we want to solve for tan theta of minus 1, then I would have to find the arctan of both sides. So that gives me tan of the arctan of minus 1, and this actually gives us minus 45 degrees, which is equivalent to 135 degrees. Remember, we learned trigonometry last semester, and we learned how to transform some of these things into as in positive degrees. So that is what we get for that. And remember, we are actually having two angles between them. That's why the question was, at what angles? I mean, it should have been an S. We have two angles between them. Just from the diagram you can see that. So we have one angle here, we have another angle here as 180 minus theta, right? So we are going to solve that angle too quickly. So also, and in class we learned both of them, how to find both angles. So the other angle is 180 minus theta. So 180 minus theta basically is always equal to minus tan of theta, right? And we just learned that tan of theta is minus 1. So we have minus 1. This is giving us 1. So assuming I'm calling the other angle theta, which I can represent by 180 minus, I'm calling the other angle alpha, which is the same as the 180 minus the theta, then I can have that tan alpha is equal to 1. Then this would imply that alpha is equal to arctan of 1, which is a very popular degree called 45 degrees. So finally, the angles between these two inclined equations of line we were given are actually 45 and 35, so 135. So therefore the angles are 45 degrees and 135 degrees. Yeah, so thank you for today. We are going to meet next week, hopefully, to discuss other questions and probably start circles. Have a good night.